Welcome. Find a comfortable position. Close your eyes. Let your breathing slow down. We are about to begin a journey not of miles but of light years, a journey into the immense silent structure that we call home. We are going to drift through the story of our galaxy, the Milky Way. Fact 1. On a clear, dark night, far from the glow of city lights, you can see it. It appears as a faint, shimmering band of light, arcing across the entire canvas of the sky. It is not a cloud, but a river of light. To the ancient Greeks, it was the Galaxius Kyklos, the milky circle, said to be the breast milk of the goddess Hera, spilled across the heavens. From this single ancient story, we derive our modern word, galaxy. Fact 2. This river of light has captivated humanity for as long as we have looked up. The ancient Egyptians saw it as a celestial river, a heavenly counterpart to their own Nile, upon which the sun god Ra sailed his boat. The Norse people saw it as the path to Valhalla, the Bifrost Bridge. The Sand people of the Kalahari tell a story of a girl who, wanting a dark sky, threw glowing embers from a fire into the heavens, and these embers became the Milky Way. For all of human history, this band was a myth, a legend, a divine boundary. Fact 3. Then, in the year 1610, a man named Galileo Galilei pointed a new invention, a simple telescope, toward this milky band. In that moment, the myth was shattered and replaced by a truth that was infinitely more profound. He saw that the river was not a smooth, flowing mist. It was composed of stars, countless individual pinpricks of light, too faint and too numerous for the naked eye to resolve. He wrote that he saw stars so numerous as to be almost beyond belief. Fact 4. What Galileo had discovered was the true nature of our home. The Milky Way is not a band in the sky. It is the sky. We are looking at our own galaxy, but from the inside. Imagine living inside a perfectly flat, thin dinner plate. If you look toward the center or toward the edge, you see the plate stretching away from you. That is what we see at night. We are looking edge-on into the vast, flat disk of our own galaxy. The river of light is the combined, distant glow of billions of other stars, all stacked up in our line of sight as we look toward the galactic center. Fact 5. Our galaxy is classified as a barred spiral galaxy. For a long time, we thought it was a simple spiral like a beautiful pinwheel. But modern observations have confirmed a different shape. At its very center is not a simple point, but a vast, dense, elongated structure of stars. A bar. This bar is enormous, perhaps 27,000 light-years long, and from the two ends of this massive bar, the great spiral arms of the galaxy begin their graceful curving journey outwards. Fact 6. The Milky Way is composed of 4 primary components. The first is the one we live in, the disk. This is the thin, flat, rotating part that contains the spiral arms and the vast majority of the galaxy's gas, dust, and young, bright stars. It is the bright, active, living part of the galaxy. It is the city itself. Fact 7. The second component is the central bulge. This is a dense, tightly packed, somewhat football-shaped region of space that surrounds the galactic center, including the bar. The stars here are ancient. They are mostly old, red, and golden stars that have been orbiting the core for billions of years. It is the old, crowded, downtown core of our cosmic city. Fact 8. The third component is the stellar halo. Surrounding the entire visible disk and bulge is a vast, spherical, ghostly cloud. This halo is incredibly sparse, populated by very old individual stars and ancient globe-like clusters of stars, known as globular clusters. These are like ancient snow globes, each containing hundreds of thousands of stars, all bound by their own gravity, and all orbiting the galactic center in wide, strange, elliptical paths. Fact 9. The fourth and largest component is invisible. It is the dark matter halo. We now know that all the stars we can see, all the gas, all the dust, all the stuff of our galaxy, is just the visible part. It is like the foam on a great invisible ocean. Surrounding everything and extending far beyond the visible light is an immense sphere of an unknown substance called dark matter. This invisible halo provides the vast majority of the galaxy's mass, and its gravity is the unseen hand that holds the entire structure together. Fact 10. The scale of our galaxy is difficult to comprehend. The visible disk, the part with the spiral arms, is estimated to be about 100,000 light-years from one edge to the other. A light-year is the distance light travels in 1 year. Light, the fastest thing we know, travels at 186,000 miles, every single second. Even at this impossible speed, a beam of light would take 100,000 years to cross our galaxy. Fact 11. Let us try to feel this scale. Our entire solar system out to the farthest, most distant planet, Neptune, is about 0.0008 light-years across. If you were to shrink the entire Milky Way galaxy down to the size of the entire North American continent, our whole solar system from the Sun to Neptune would be smaller than a quarter. It would be an invisible speck of dust, lost somewhere in the middle of a continent-sized pinwheel. Fact 12. Our own sun, the star that gives us life, is just one of many. For a long time we did not know how many. We now estimate that the Milky Way contains between 100 billion and 400 billion stars. For every single person who has ever lived, there are at least 20 stars in our galaxy alone, and many of those stars have planets. The numbers suggest there could be billions of planets in our galaxy. Just like Earth. Fact 13. The disk of our galaxy is not just wide. It is incredibly thin. While the disk is 100,000 light-years across, it is, on average, only about 1,000 light-years thick. This gives it a proportionality that is thinner than a typical vinyl record. We are living inside this incredibly delicate, thin, spinning plane of light. Fact 14. We do not live in the center of this disk. Our solar system, our sun, and our Earth are located in the galactic suburbs. We are about 27,000 light-years away from the galactic core. We are about halfway from the center to the outermost edge. Our position is quiet. We are far from the chaos, radiation, and intense gravitational forces of the crowded galactic center. Fact 15. Our specific neighborhood is known as the Orion Arm, or, more accurately, the Orion Spur. The Milky Way has 4 great primary spiral arms. 2 major arms are named the Perseus Arm and the Scutum Centaurus Arm. We are not in one of these main highways. We are located on a smaller partial arm, a kind of branch or spur that sits between these 2 larger arms. It is a quiet residential street off the main galactic highway. Fact 16. This location is incredibly fortunate. It is in what scientists call the galactic habitable zone, like the Goldilocks zone around a star, where water can be liquid. The galaxy itself has a Goldilocks zone. If we were too close to the center, the radiation from the core and the frequent explosions of dying stars called supernova would make complex life impossible. If we were too far out in the distant edges of the galaxy, there would not be enough metals, elements heavier than hydrogen and helium, which are forged in stars to build rocky planets like Earth, or to create the building blocks of life. We are in the sweet spot for life. Fact 17. Our galaxy is not still. It is in constant swirling motion. Every star, every planet, every cloud of gas is in a continuous, silent orbit around the galactic center. The Milky Way spins, but it does not spin like a solid object. Stars closer to the center complete their orbits faster than stars farther out. This is called differential rotation. It is a vast, complex gravitational dance. Fact 18. Our sun is part of this dance. You are at this very moment moving through space at a staggering speed. Our entire solar system is traveling at approximately 483,000 miles per hour, or 220 kilometers per second. In the few moments you have been listening, you have traveled thousands of miles through the galaxy. Yet the distances are so great, this speed feels like a perfect stillness. Fact 19. Even at this incredible velocity, it takes our sun a very long time to complete one full circuit of the galaxy. The time it takes for our solar system to make one full orbit around the center of the Milky Way is called one galactic year or one cosmic year. This single year, this one orbit, takes approximately 230 million Earth years. Fact 20. This cosmic timescale helps us see our true place in history. Our sun is about 4.6 billion years old. This means that in its entire lifetime, our sun has only completed this grand orbit about 20 times. Our Earth has seen only 20 galactic New Years. The last time our solar system was in this exact spot in the galaxy, 230 million years ago, the very first dinosaurs were just beginning to walk the Earth. The great supercontinent of Pangaea was just beginning to break apart. Fact 21. All of human history, from the first civilizations in Mesopotamia to the rockets we send to the moon, has taken place in a tiny fraction of this journey. If the entire 2-100-and-30-million-year galactic year were compressed into a single 24-hour day, all of recorded human history would be over in less than 2 seconds. We are infants, adrift in an ancient spinning city of stars, our home, the Milky Way. Fact 22. Our galaxy is a structure of profound elegance. It is not a random spray of stars, but a highly organized, self-gravitating system. We call it a barred spiral galaxy. Imagine a vast, spinning hurricane of stars, frozen in time. At its center, a dense, glowing bar of light. And from this bar, 2 majestic arms begin to curl, wrapping themselves around the core, with fainter arms branching off, all held in a delicate, spinning balance. This is the grand design. Fact 23. For a very long time we could not see this design. We are inside it. It is like trying to draw a map of your entire city while standing in a single, narrow alleyway. The dust and gas of the galaxy, the smog of our own neighborhood, blocks our view. We could only map our local area. It was not until we built telescopes that could see in different kinds of light radio waves and infrared that we could finally pierce the veil of dust and begin to trace the true grand shape of our home. Fact 24. The most prominent features of this design are the spiral arms. These are the bright, winding lanes of our galactic city. We believe the Milky Way has 4 primary arms, though 2 are more prominent than the others. The 2 major arms are named the Scutum Centaurus arm and the Perseus arm. The 2 minor, or fainter, arms are the Norma arm and the Sagittarius arm. We, in our Orion spur, are tucked between the Sagittarius and Perseus arms. Fact 25. But what is a spiral arm? It is not a solid object. It is not a permanent, fixed thing that moves together like a great sweeping pipe. If it were, it would wind itself up tightly after just a few rotations and disappear. The arms are, instead, a density wave. They are a pattern, a slow-moving traffic jam in space. The arms themselves are waves of higher gravity, and they move through the disk more slowly than the stars and gas do. Fact 26. As stars and, more importantly, vast clouds of hydrogen gas orbit the galaxy, they eventually catch up to one of these slow-moving density waves. When the gas cloud enters the arm, it is squeezed by this higher gravity. This compression, this squeezing, is the trigger. It causes the gas cloud to collapse in on itself in thousands of places at once, igniting a furious wave of new star formation. Fact 27. This is why the spiral arms are so bright. They are not bright because they contain more stars, but because they contain the youngest and brightest stars. They are the celestial nurseries of the galaxy. They are the glittering, active, downtown streets where all the action is. The arms are where stars are born. Fact 28. When we look at other spiral galaxies, we see these arms glowing with two distinct colors. They glow a brilliant electric blue and a soft, deep pink. The blue light is from the new stars. These are the O-type and B-type stars, massive, hot, and incredibly luminous. They burn their fuel so quickly that they live for only a few million years. They are born in the arm, and they die in the arm, never living long enough to drift out. Fact 29. The pink, glowing regions are called H2 regions, or emission nebulae. The intense ultraviolet light from those new hot blue stars shines onto the leftover hydrogen gas that surrounds them. This energy excites the gas, causing it to glow in a specific shade of reddish pink. Our own local Orion Nebula is one of these regions, a small pocket of starbirth in our own quiet spur. The spiral arms are painted in these colors of creation. Fact 30. Let us trace these great arms. The Scutum Centaurus arm is a major arm. It begins at one end of the central bar and winds its way outwards. It is a long, continuous arm, dense with gas and packed with star-forming regions. When we look towards the constellation Sagittarius, towards the galactic center, we are looking through this arm. It is one of the brightest and most complex sections of the Milky Way. Fact 31. Further out is the Perseus arm. This is the other major arm, and it is the great arm that lies just outside of our own position. When you look up at the winter sky into the constellation Perseus, you are looking outwards from our sun towards this grand, sweeping structure. It is home to many famous objects, including the dazzling double cluster in Perseus and the ghostly remnant of the Crab Nebula. Fact 32. Closer in than our arm is the Sagittarius arm. It is a minor arm, but it is very active. It is so rich in star-forming regions that it contains some of the most beautiful sights in our sky, including the Lagoon Nebula, the Trifid Nebula, and the Omega Nebula. It is a bright, knotty, and dynamic part of the inner galaxy. Fact 33. These arms are not static. They are the weather of the galaxy. They are transient, evolving features. They form, they merge, they can be sheared apart by the galaxy's rotation. They are the visible, fleeting patterns of a deep, underlying gravitational dance that lasts for billions of years. Fact 34. Now let us travel to the center, to the feature that anchors this entire system. For decades, astronomers debated, were we a simple spiral galaxy or something else? In the 1990s, observations from infrared telescopes, which can see through the thick dust that blocks our view, gave us the answer. We are a barred spiral. At the very heart of the Milky Way is not a point, but a vast, elongated, peanut-shaped structure composed of billions of stars. Fact 35. This central bar is immense. It is thought to be about 27,000 light-years long from end to end. This means the bar itself is as large as the entire distance from our Sun to the galactic center. It is a colossal feature. It is oriented at an angle of about 45 degrees relative to the line connecting our Sun and the galactic center. Fact 36. Unlike the spiral arms, which are full of new blue stars, the central bar is composed almost entirely of old stars. They are ancient. They are red giants and old yellow stars packed together in a dense, glowing hub. This bar is a stable, mature feature of our galaxy, and it has likely existed for most of our galaxy's life. Fact 37. This bar is not just sitting there. It rotates. But it rotates differently from the rest of the galaxy. It spins as a solid object, like a great rod stirring a vast pool of water. Its ends sweep through the inner galaxy, and its gravity has a profound effect on the entire disk. Fact 38. The bar acts as a great gravitational funnel. Its powerful rotating gravity shepherds the gas and dust in the inner regions of the galaxy. It disrupts stable orbits and channels a steady stream of material, gas, dust, and even stars inwards, away from the disk and down towards the very, very center. The bar is the engine that feeds the mysterious, dark heart of our galaxy. Fact 39. We have seen the flat disk, with its arms and bar, but our galaxy is not just flat. Surrounding the entire disk, above it and below it, is a vast, spherical, ghostly cloud. This is the stellar halo. This is the ancient attic of our galaxy. It is enormous, perhaps 200,000 light-years across, and the disk is just a thin plane of light embedded within it. Fact 40. The halo is sparsely populated. It contains only about 2% of the galaxy's stars, and the stars it does contain are different. They are population 2 stars. This means they are incredibly old and metal poor. They are made almost entirely of the original elements from the Big Bang, hydrogen and helium. They are the first-generation immigrants, the survivors from the very birth of our galaxy. Fact 41. These halo stars do not travel with us in the disk. They are on their own strange paths. Their orbits are not neat circles. They are highly elliptical, like the orbits of comets. They plunge down through the galactic disk at high speeds, pass through the other side, and then fly tens of thousands of light years out into the blackness of the halo, before gravity pulls them back to do it all over again. Fact 42. The halo is also home to the most ancient and beautiful objects in our galaxy, the globular clusters. There are about 150 of these that we know of orbiting our galaxy like ancient, silent satellites. Fact 43. A globular cluster is a wonder. It is a perfectly spherical, densely packed ball of stars. Each cluster contains hundreds of thousands or even millions of stars, all held together by their own intense collective gravity. They are like miniature spherical galaxies. Fact 44. The stars inside these clusters are all ancient. They were all born at the same time, from the same giant cloud of gas, more than 12 billion years ago. This makes them some of the oldest objects in the entire universe. They are like fossils. They are time capsules preserving the conditions of the cosmos just after the dawn of time. Fact 45. If you were to live on a planet inside a globular cluster, the night sky would be unlike anything we can imagine. The center of the cluster is so dense that stars are packed in thousands of times more tightly than in our neighborhood. The sky would not be dark. It would be ablaze with thousands of stars, many shining with the brightness of our full moon, a constant, glittering canopy of light. Fact 46. The halo is also a graveyard. As astronomers study the motions of stars in the halo, they find streams, long river-like processions of stars, all moving together on the same path. These are not original to our galaxy. They are the torn apart, shredded remnants of smaller, dwarf galaxies that the Milky Way's immense gravity has captured and consumed over billions of years. Our halo is built from the ghosts of the galaxies we have eaten. Fact 47. Now let us return to the rotation. The entire structure, the disk, the bar, the halo, is spinning. But it spins in a way that defied all our laws of physics. We expected it to spin like our solar system. According to Kepler's laws of gravity, objects farther from the center should move more slowly. In our solar system, Mercury moves very fast, while distant Neptune crawls along. We thought the galaxy's edge would be slow. Fact 48. This is not what we found. When astronomers like Vera Rubin in the 1970s measured the rotation speed of stars, they found something impossible. The stars on the very outer edges of the galaxy, far from the bright center, were moving just as fast as the stars closer in. The galaxy's rotation curve was flat. Fact 49. This discovery was world-changing. The stars on the edge were moving so fast that the gravity from all the visible matter, all the stars, gas, and dust we could see should not be enough to hold them. The galaxy should be flying apart. The stars on the outer rim should be flung off into the intergalactic void, like children letting go of a merry-go-round that is spinning too fast. Fact 50. But they are not flying off. The galaxy is stable. This was the first and strongest piece of evidence that there is more to our galaxy than we can see. There must be a huge, unseen, invisible mass, a halo of something else, ... providing the extra gravity needed to bind the galaxy together. This invisible substance is what we now call dark matter. Fact 51. This is the final and largest piece of the grand design. The visible Milky Way, the beautiful pinwheel of stars, the bar, the halo ... all of it, is just a small, glittering component. It is a fragile structure of light, sitting inside a much, much larger, completely invisible, and profoundly mysterious sphere of this dark matter. This dark halo is the true architect. It is the unseen scaffold that dictates the motion, the structure, and the ultimate fate of our grand, spinning city. Fact 52. Let us now drift away from the grand structure and focus on the citizens of this city, the stars themselves. But before a star can be born, there must be the stuff of stars. Our galaxy is not empty. The space between the stars is filled with a vast, diffuse, and vital substance. We call it the interstellar medium. It is the air, the water, and the soil of the galaxy. Fact 53. This medium is itself made of two things, gas and dust. The gas is almost entirely hydrogen and helium, the raw, original elements forged in the Big Bang. These are the fundamental building blocks. This gas is not spread evenly. It gathers in colossal, cold, dark clouds ... Clouds so large they can be hundreds of light years across, containing enough mass to build 1,000,000 suns. These are the giant molecular clouds. Fact 54. These clouds are the true stellar nurseries. They are cold, dense, and dark. If you were to float inside one, you would see nothing. The blackness would be absolute. The temperatures here are just a few degrees above absolute zero, the coldest it is possible to be. It is in this perfect, cold, still darkness that the seeds of new stars begin to form. Fact 55. The second part of this medium is dust. This is not like the dust in your home. This is a fine, microscopic soot. It is made of tiny grains of silicates, like sand and carbon, like graphite, and frozen ices like water and ammonia. This dust is created in the atmospheres of old, dying red giant stars and blasted out into space by the explosions of supernova. It is the ash of long-dead stars. Fact 56. This cosmic dust is incredibly important. It is the smog of our galaxy. It is what blocks our view of the galactic center. This dust is very good at blocking visible light, scattering the blue light and letting the red light pass through. This is called interstellar reddening. It is why distant stars often look redder than they truly are. It is the same reason our own sun appears red at sunset, as its light passes through the dust in Earth's atmosphere. Fact 57. Where this dust is thick, it creates the most hauntingly beautiful objects in the sky, dark nebulae. These are not places without stars. They are places where a thick, cold cloud of dust is sitting in front of the stars, blocking their light completely. They look like holes in the heavens or silhouettes against the starry background. The famous Horsehead Nebula is one such object, a dark shadow against a bright, glowing pink cloud. Fact 58. Now let us return to the cold, giant molecular clouds. Inside this darkness, gravity begins its slow, patient work. A nearby disturbance, perhaps the shock wave from a distant supernova, or the gravitational nudge from a passing star, causes a small part of the cloud to become unstable. It begins to collapse. A dense knot of gas and dust begins to pull in more and more material, falling in on itself, spinning faster and faster, like water going down a drain. Fact 59. As this knot, called a protostar, collapses, it begins to heat up. The pressure at its core builds to unimaginable levels. For thousands of years, it is just a warm, glowing object, hidden deep inside its dusty cocoon. Then a critical moment is reached. The core becomes so hot, so dense millions of degrees that a new kind of fire is lit. Nuclear fusion begins. Hydrogen atoms are forced together to create helium. In this moment, a star is born. Fact 60. The new star awakens. A tremendous blast of radiation and a powerful stellar wind blows outwards from the star, evaporating and blasting away its birth cocoon, its dusty shell. The star emerges, brilliant and shining, onto the galactic stage. Often, a star is not born alone. The giant cloud fragments into hundreds or thousands of points of collapse at once. They are born as a family. Fact 61. This family of new stars, all born from the same cloud at the same time, is called an open cluster. They are young, hot, and loosely bound by gravity. They travel together through space for a few 100 million years, like a glittering swarm of bees. The most famous example in our sky is the Pleiades, or the Seven Sisters. A small, shimmering dipper of bright blue, newborn stars, still wreathed in the faint, blue, misty remnants of the gas cloud they were born from. Fact 62. When a massive star is born, its birth is far more violent. These are the O-type and B-type stars. They are so hot, so powerful, that their intense ultraviolet radiation ionizes the gas cloud around them, causing it to glow with a brilliant pink or red light. These are the emission nebulae, or H2 regions, that we see painting the spiral arms. The Orion Nebula is the closest and most famous of these, a vast, chaotic, glowing cavern of gas where thousands of new stars are being born right now. Fact 63. So, how many stars has our galaxy made? The stellar population of the Milky Way is estimated to be between 100 billion and 400 billion stars, a truly staggering number. If you were to count one star every second without rest, it would take you over 3,000 years to count just 100 billion of them. Fact 64. And these stars are not all the same. They come in a vast range of sizes, colors, and temperatures. The most common type of star in our galaxy is not like our sun. By a huge margin, the most numerous stars are red dwarfs or M-type stars. These are the quiet, forgotten majority. Fact 65. Red dwarfs are small, cool, and dim. They are perhaps only 10 to 20% the mass of our sun. They sip their hydrogen fuel so slowly, so efficiently, that their lifespans are almost eternal. A red dwarf can live for trillions of years. Since our universe is only 13.8 billion years old, not a single red dwarf that has ever been created has had time to die. They are the silent, simmering, everlasting embers of the cosmos. Fact 66. Then there are stars like our sun, a G-type yellow dwarf star. We think of it as average, but it is actually brighter and more massive than about 90% of all the stars in the galaxy. Our sun is a calm, stable, middle-aged star. It is about 4.6 billion years old, and it is about halfway through its total 10 billion year lifespan. It is the perfect steady star to nurture life on a nearby planet. Fact 67. And then there are the giants, the rare, brilliant, blue O-type stars. These stars are titans. They can be 50 or 100 times more massive than our sun, and shine with a brilliance millions of times greater. But they pay a heavy price for this power. They burn through their fuel at a ferocious, reckless rate. They live fast and die young. A blue giant star may live for only a few million years, a mere cosmic heartbeat, before it destroys itself in a cataclysmic explosion. Fact 68. As we learned in the halo, there are also different generations of stars. Population I stars are stars like our sun. They are metal-rich. This means they contain about 2% of metals, which to an astronomer is any element heavier than hydrogen and helium. This 2% is the recycled ash of older, dead stars. These are the younger stars found in the thin disk, and they have the raw materials to form rocky planets. Fact 69. Population II stars are the ancient, metal-poor stars we find in the halo and the globular clusters. They are made of almost pure, original hydrogen and helium. They are fossils, born at a time before the galaxy had had time to create and recycle heavy elements. There is even a theoretical first generation, population III, made only of hydrogen and helium, but we have not yet found one. They would be the first stars ever to light up the universe. Fact 70. All stars must one day die. Their story ends when they run out of hydrogen fuel in their core. For a star like our sun, this will happen in about 5 billion years. When the hydrogen is gone, the core will collapse, and the outer layers of the star will swell, cool, and expand. Our sun will become a red giant. Fact 71. As a red giant, our sun will grow to an enormous size. It will swell up to 100, perhaps 200 times its current diameter. It will become so large that it will swallow the orbits of Mercury and Venus, and possibly Earth. The star that gave us life will, in its old age, become our destroyer. Fact 72. But this is not the end. After this red giant phase, the sun's core will become unstable. It will begin to pulse gently at first, and then more violently. With each pulse, it will puff its outer layers of gas off into space. These layers will expand outwards as a beautiful, glowing, intricate shell. This is a planetary nebula. Fact 73. These are some of the most beautiful objects in the cosmos. They are the final, graceful sigh of a dying, sun-like star. They look like rings or hourglasses or ghostly, cosmic eyes looking back at us. The Ring Nebula or the Cat's Eye Nebula are famous examples. They are a star's final brief gift of beauty to the galaxy. They last for only 10,000 years, a fleeting moment, before their gas fades and disperses back into the interstellar medium. Fact 74. And what is left behind? At the center of the planetary nebula, the star's old, dead core remains. This core is now a white dwarf. It is an object of incredible density. It is the mass of our sun, crushed down into a sphere the size of the Earth. A single teaspoon of white dwarf material would weigh as much as a truck. Fact 75. This white dwarf is no longer a star. It generates no new heat. It is a cooling ember. It is a diamond in the sky, a hot, dense crystal that will simply radiate its leftover heat into space for billions and trillions of years until it finally fades to a cold black cinder, a black dwarf. This is the gentle, quiet death that awaits most stars in our galaxy. Fact 76. But the massive stars, the blue giants, their death is anything but gentle. When they run out of fuel, their core collapses not in a pulse, but in a catastrophic, sudden implosion. The collapse is so fast, so violent, that it rebounds in the single most powerful explosion in the universe, a supernova. Fact 77. In one brilliant flash, a single exploding star can outshine its entire galaxy. It will blaze with the light of 100 billion suns for a few weeks. The energy released is incomprehensible. This explosion is the forge of the elements. The heat and pressure are so intense that they fuse simple atoms into complex ones: gold, silver, platinum, uranium. All the heavy elements in the universe are created in this single fiery moment. Fact 78. This explosion blasts these new heavy elements out into the galaxy at enormous speeds. These elements enrich the giant molecular clouds. This means the next generation of stars that forms from these clouds will have these elements. They will have the metals needed to form planets. The iron in your blood, the calcium in your bones, the oxygen you are breathing, all of it was forged in the heart of a supernova billions of years ago. We are, in the most literal sense, made of stardust. Fact 79. And what is left behind after this explosion? For some stars, the core collapses into a neutron star. This is an object that is even denser than a white dwarf. It is a star more massive than our sun, crushed into a ball only 10 or 15 miles across, the size of a single city. The gravity is so strong that electrons and protons are squeezed together to form a perfect sphere of pure neutrons. A single sugar cube of neutron star material would weigh 100 million tons. Fact 80. Many of these neutron stars are spinning incredibly fast, hundreds of times per second. They have powerful magnetic fields that shoot out beams of radiation like a lighthouse. As the star spins, this beam sweeps across the cosmos. If it sweeps across Earth, our radio telescopes hear a pulse. We call this a pulsar. It is the ticking cosmic heartbeat of a dead star. Fact 81. But for the most massive stars of all, even the neutrons cannot stop the collapse. When the star explodes, its core continues to fall in on itself forever. It crushes itself down past the size of a white dwarf, past the size of a neutron star. It crushes itself down to a point of zero size and infinite density. A singularity. Fact 82. Around this point it creates a region of space where gravity is so powerful, so warped, that nothing, not even light itself, can escape. It creates a stellar mass black hole. This is the final and most mysterious end for the greatest stars. They do not fade away. They do not leave a beautiful remnant. They simply vanish, leaving behind only their gravity. A silent, invisible tear in the fabric of the galaxy. Fact 83. We have journeyed through the quiet suburbs and traced the great star-filled arms. Now we travel to the most extreme, most violent, and most mysterious place in our entire galaxy. We are going to the center. We are going to the heart of the Milky Way. If you look up at the summer sky towards the constellation Sagittarius, you are looking in this direction. You will see the brightest, densest part of the Milky Way's river of light, but you are not seeing the center. You are only seeing the glowing fog that lies in front of it. Fact 84. The true galactic center is invisible. It is completely, totally, and utterly hidden from our eyes. It is forever shrouded. The reason is the same interstellar dust that paints our sunsets. Between us and the galactic center, a distance of 27,000 light years, lie vast, thick, cold clouds of this cosmic dust. These clouds are so dense that they form a great dark slash across the bright bulge. Astronomers call it the Great Rift. This rift is a wall of dust that blocks almost all visible light. Fact 85. This veil of dust is almost impossibly thick. It creates what is called extinction. The light from the galactic center is dimmed by a factor of 1 trillion. This means that for every 1 trillion photons of visible light that leave a star at the galactic center, only one single photon will make it all the way to Earth. It is the most perfect curtain in the cosmos. For all of human history, the heart of our galaxy was a complete mystery. Fact 86. But in the 20th century, we learned to see with new eyes. We built telescopes that could detect light our eyes cannot. We built radio telescopes, which see the long, lazy waves of radio light. And we built infrared telescopes, which can detect heat. These two kinds of light, infrared and radio, are not easily blocked by dust. They can pass right through the Great Rift. When we first pointed these new telescopes at Sagittarius, the veil was finally lifted, and what we found was a place of unbelievable chaos and power. Fact 87. The first thing we saw was the central bulge. This is the dense, football-shaped hub of the galaxy. It is about 10,000 light years across, and it is packed with ancient stars. Unlike the disk, which is full of young blue stars and gas, the bulge is a place of old, red and yellow stars all orbiting the center in a frantic, buzzing swarm, like bees around a hive. The density of stars here is extreme. Fact 88. In our own solar neighborhood, we are lonely. The nearest star to our sun, Proxima Centauri, is over 4 light years away. If you were to travel at the speed of our fastest space probes, it would take you over 70,000 years to reach it. But in the central bulge, stars are crowded in millions of times more densely. If we lived there, our night sky would be a solid blazing wall of light. There would be thousands of stars brighter than our full moon. There would be no night, only a perpetual golden twilight. Fact 89. As we push deeper into the very innermost few hundred light years, we find some of the most spectacular and short-lived objects in the galaxy. Here we find the Arches cluster and the quintuplet cluster. These are young super-star clusters. They are so dense that they contain tens of thousands of young stars, including some of the most massive and luminous stars known to exist, all packed into a space just a few light years across. Fact 90. The stars in these clusters are true titans. They are stars 100 times more massive than our sun, and millions of times brighter. They are so powerful that their stellar winds, the gas they blow off their surfaces, travel at thousands of miles per second. Where these winds collide with each other, they create shock waves that heat gas to millions of degrees, causing it to glow in X-rays. This is a region of intense cosmic violence. Fact 91. Now we journey to the final innermost region, a place astronomers call the central parsec. A parsec is about 3.26 light years. So this is a small box, just 3 light years on each side, right at the very heart. The conditions here are almost unimaginable. We are at the bottom of the galaxy's gravitational well. Everything is moving at incredible speeds, pulled by an immense unseen force. Fact 92. In 1933, an engineer named Carl Jansky was studying radiostatic for Bell Labs. He found a faint, persistent hissing sound coming from the sky. He traced it. The source of this hiss was not on Earth. It was not in our solar system. It was coming from the exact center of the Milky Way in the constellation Sagittarius. This was the first time humanity had ever detected a signal from the galactic heart. We had heard the monster before we could see it. Fact 93. This radio source was given a name. It was called Sagittarius A. As our telescopes improved, we saw that Sagittarius A was a complex, swirling region of hot gas and magnetic fields. But right at its very center was one tiny, incredibly bright pinprick of radiolight, a point that was not moving at all. This object was named Sagittarius A*, pronounced a star. This single, unmoving point is the gravitational anchor of our entire galaxy. Fact 94. For decades we suspected what it was. A black hole. But not just any black hole. A supermassive black hole. A monster, but suspicion is not proof. The proof came in the 1990s and 2000s from the patient work of 2 separate teams of astronomers, led by Reinhard Genzel and Andrea Ghez. They used the largest telescopes on Earth, equipped with cutting-edge technology to cancel out the blurring of our own atmosphere. Fact 95. They pointed their telescopes at that central, invisible point, and they watched. Not for a night, not for a year, but for decades. They were watching the stars in the central parsec. They were tracking their movements year after year after year. They were watching a tiny cluster of stars known as the E-Cis stars that were orbiting this invisible point. Fact 96. And what they saw was breathtaking. These stars were moving at impossible speeds. One star named S2 was seen completing a full orbit. Its path was a perfect Keplerian ellipse. It was orbiting something, but the speeds were mind-boggling. As S2 got closer to the invisible center, it accelerated. It reached a top speed of over 17 million miles per hour. That is 2.5% the speed of light. Fact 97. This was the smoking gun. Using the laws of gravity, the same laws that keep our Earth orbiting the Sun, the astronomers could use the orbit of S2 to weigh the object it was orbiting. The calculation was simple, and the answer was staggering. To make S2 move that fast and that small of an orbit, the central object had to have a mass of 4 million times the mass of our Sun. Fact 98. And all of this mass, the mass of 4 million suns, had to be crammed into a region of space smaller than the orbit of Mercury. There is only one object in the universe that can be that massive and that small, and be completely invisible: a supermassive black hole. After decades of searching, we had finally found it. We had found the heart of our galaxy. Fact 99. So what is Sagittarius A*? It is a black hole, an object of pure warped space-time. Its mass is 4 million suns, but its size, its physical boundary, the point of no return, known as the event horizon, is tiny. Its diameter is only about 15 million miles. This is enormous to us, but on a cosmic scale it is minuscule. It would fit easily inside the orbit of Mercury. It is a point of unimaginable density, anchoring a city of billions of stars. Fact 100. Compared to the black holes we see in other, more active galaxies, Sagittarius A* is a sleeping giant. It is quiet. Other black holes are quasars, actively feeding on billions of stars and clouds of gas, and shining with a light that outshines their entire galaxy. Our black hole is not. It is on a starvation diet. It is mostly dormant. Fact 101. But it is not completely dormant. We see it flicker. Astronomers observe powerful flares of X-ray and infrared light bursting from the region, sometimes daily. These flares are the black hole snacking. They are caused by small clumps of gas or perhaps an unlucky asteroid getting too close. As they fall in, they are torn apart by the tidal forces and superheated to millions of degrees, releasing one final brilliant flash of light before they cross the event horizon and are lost from our universe forever. Fact 102. Even though it is quiet, it is not alone. It is surrounded by a swirling, chaotic disk of hot gas. This is the accretion disk. This is not a stable, neat disk, but a turbulent, thin fog of material that is slowly, over millions of years, being pulled into the black hole. The S stars, like S2, are on a precarious, dangerous dance. On every orbit, they must plunge through this hot, gaseous disk as they whip around the black hole at blinding speeds. Fact 103. In 2014, the world's astronomers watched in anticipation. A strange, elongated cloud of gas, named G2, was discovered to be on a direct collision course with the black hole. We thought we were about to see our monster truly feed. We expected the cloud to be torn to shreds, superheated, and to cause a massive, brilliant flare as it was devoured. Fact 104. But nothing happened. The cloud, G2, swung around the black hole, was stretched out like spaghetti, and it survived. It emerged on the other side and continued on its orbit. This surprising event suggests that G2 was not just a simple cloud of gas. It may have a hidden, dense star at its core, and the star's gravity was just enough to hold the cloud together as it skimmed the edge of oblivion. Fact 105. This central parsec is a place of profound paradoxes. It is the most destructive place in the galaxy, home to a monster that can swallow stars whole. And yet, we see evidence of star birth. We see young, massive stars orbiting the black hole in a place where the gravity should be too intense, the tidal forces too strong, to ever allow a cloud of gas to collapse and form a star. How they got there, whether they were born there or were captured and dragged in, is one of the greatest unsolved mysteries of our galactic center. Fact 106. This is the heart of our galaxy. Sagittarius A**. A single, silent, invisible point, 4 million times the mass of our sun. Every star you have ever seen, every planet, every nebula, our own sun, and our own Earth, all of it, is held in a graceful, trillion-mile-wide orbit, anchored by the gravity of this single, mysterious, sleeping monster. Fact 107. We have explored our galaxy's light. The brilliant stars, the glowing pink nebulae, the crowded golden core. Now we must journey into its shadow. We must explore the galaxy that we cannot see. For all that we have discussed, all the stars, all the gas and dust, all of it is just a tiny fraction of the whole. It is the visible, glittering foam on the shore of a vast, dark, invisible ocean. Fact 108. The first clue to this invisible world came from a simple, profound observation, a mystery we touched on earlier, the rotation of our galaxy. In the 1970s, astronomers like Vera Rubin patiently measured the speeds of stars in distant galaxies, and later in our own. They expected to see the galaxy rotate like our solar system. Stars far from the center should move much, much more slowly than stars closer in. Fact 109. They did not. What they found was impossible. The stars on the very outer visible edge of the galaxy were moving just as fast as stars near the middle. This observation, the flat rotation curve, defied all known laws of gravity. If the only matter in the galaxy was the stuff we could see, all the stars and all the gas, these outer stars would be moving far too fast to be held in orbit. They should be, at this very moment, flung off into the blackness of intergalactic space. Fact 110. But they are not. They are held in their orbits. The conclusion was inescapable and world-changing. There must be an immense, unseen, and unknown mass, a vast halo of something else, providing the extra gravity needed to bind the galaxy together. This was the discovery of dark matter. Fact 111. This is not just a small missing piece of the puzzle. It is the puzzle itself. The numbers are staggering. We now believe that for every pound of normal matter, the baryonic matter that makes up you and me and the sun and all the stars in the sky, there are at least 5 pounds of this dark matter. The Milky Way, our brilliant city of light, is in reality over 85% invisible. Fact 112. This dark matter halo is not a thin ring or a distant cloud. It is a colossal, spherical, or perhaps slightly flattened sphere of invisible mass that surrounds everything. The bright, visible disk of the Milky Way is just a small, glittering pancake sitting in the very, very center of this immense dark sphere. The halo is the galaxy. We are just the visible part. Fact 113. So what is this mysterious substance? For decades we have tried to find it. We can begin by ruling out what it is not. It is not, for example, just vast clouds of normal, cold gas or dust that we cannot see. If it were, it would still block or absorb the light from distant galaxies behind it, or at least glow faintly in infrared light from its own minuscule heat. It does neither. It is completely transparent. Fact 114. It is also not a huge collection of normal but dark objects, like planets, cold dead white dwarfs, neutron stars, or millions of stray stellar mass black holes. Astronomers had a name for this idea. They called them MACHOs, which stands for Massive Compact Halo Objects, and they went hunting for them. Fact 115. The search for MACHOs was one of the most clever experiments ever devised. Astronomers monitored millions of stars in a nearby galaxy, the Large Magellanic Cloud. They were looking for a tiny, rare event. If a macho, a dark black hole or white dwarf from our own halo, were to pass exactly in front of one of those distant stars, its gravity would bend the star's light, acting like a lens. This gravitational microlensing would cause the distant star to temporarily and very briefly brighten and then fade. Fact 116. After years of patiently watching, they found ... some. They saw a few of these brightening events, confirming that yes, there are dark MACHOs in our halo, but they found nowhere near enough. The number of events they detected could only account for a tiny, tiny fraction of the missing mass. The conclusion was profound. Fact 117. The dark matter, the vast majority of our galaxy, is not made of atoms. It is not made of protons, neutrons, or electrons. It is not normal matter of any kind. It must be something else entirely. It is non-baryonic. It is an exotic, new, undiscovered particle. Fact 118. This particle must be from a dark sector of physics, a substance that does not interact with light, which is why we cannot see it. It does not interact with electricity or magnetism. It may not interact with any force in the universe except for the single universal force of gravity. Fact 119. The leading hypothesis is that this particle is a WIMP, or a weakly interacting massive particle. These particles would be heavy, but they would be weakly interacting, meaning they can pass through normal matter, almost as if it were not there at all. Fact 120. This theory suggests that at this very moment, as you lie here listening, billions, perhaps trillions, of these dark matter particles are streaming through the room. They are passing through the earth. They are passing through your body, as if you were a complete ghost, leaving no trace and feeling nothing. They are the silent, invisible, gravitational soul of the cosmos. Fact 121. This invisible halo is the true architect of the Milky Way. Its immense gravity in the early universe was the seed of our galaxy. It was the scaffolding that first pulled in the primordial clouds of hydrogen and helium. The visible galaxy we live in, the disk of stars, is just the normal matter that has settled, like sediment, into the bottom of this vast, dark, gravitational well. Fact 122. But dark matter is not the only invisible force at play. Our galaxy is also threaded with a vast, invisible magnetic field. This field is incredibly faint, thousands of times weaker than the small magnet that holds a note to your refrigerator. Fact 123. But this field is stretched across the entire 100,000 light-year disk. Its immense scale gives it an immense subtle power. It acts like a magnetic skeleton, helping to shape the spiral arms. It helps support the gas clouds against their own gravitational collapse, regulating the birth of stars. Fact 124. This magnetic field also serves another purpose. It acts as a cosmic trap, a vast, tangled magnetic net, and it traps the most energetic high-speed particles in the galaxy, cosmic rays. Fact 125. Cosmic rays are not light. They are physical particles. They are the hearts of atoms, mostly protons, and atomic nuclei that have been accelerated by the most violent events in the galaxy. They are the shrapnel from supernova explosions. The shock wave from a dying star acts as a colossal natural particle accelerator, blasting these particles out at unimaginable speeds. Fact 126. These tiny particles travel at over 99.9% the speed of light. They carry incredible energy. When they hit the Earth's atmosphere, they shatter atoms. They are trapped by our galaxy's magnetic field, zipping and spiraling along its invisible lines of force for millions of years, a constant, invisible rain of high-energy radiation passing through our world and our bodies every second. Fact 127. There is another, more violent, invisible feature. In the year 2010, the Fermi Gamma-Ray Space Telescope, which is designed to see the most energetic light in the universe, found something astonishing. It found two colossal, mysterious bubbles looming high above and far below our galaxy's center, where nothing was thought to exist. Fact 128. These are the Fermi bubbles. They are completely invisible in every kind of light, optical, infrared, radio, except for gamma rays. Each bubble is a giant teardrop-shaped lobe of superheated high-energy gas stretching 25,000 light-years into the galactic halo. Together, they form a single, ghostly, hourglass shape 50,000 light-years tall, with our galactic center at its pinch. Fact 129. We now believe these bubbles are the exhaust of our supermassive black hole. They are the ghostly remnants of a colossal, violent outburst, a past-feeding frenzy, that took place a few million years ago, a time when Sagittarius A* devoured a massive star or a giant cloud of gas and erupted, blasting out two powerful focused jets of energy that inflated these invisible lobes. They are a silent, gamma-ray monument to our black hole's violent past. Fact 130. Finally, our galaxy has an invisible weather system. Astronomers have found vast, continent-sized clouds of hydrogen gas high above the galactic disk in the halo. These are the high-velocity clouds, and the mystery is that they are not moving with the galaxy. They are not part of our rotation. They are moving at their own strange speeds. They are outsiders. Fact 131. These clouds are raining down onto our galaxy's disk. A galaxy is not a closed system. It must eat to live, or it would have used up all its gas long ago. This is the galaxy's fuel supply. This is the intergalactic rain, the fresh primordial hydrogen from the empty void between galaxies, being pulled in by our dark matter halo's immense gravity. This gas will, over millions of years, replenish the disk, cool, form new molecular clouds, and begin the entire cycle of star birth all over again. The invisible galaxy is not dead. It is, in every sense, alive. Fact 132. We have toured our home. We have seen its vast, spinning arms, its stellar nurseries, its ancient, dying embers, its chaotic heart, and the invisible ocean of dark matter that holds it all together. Now, in this final part of our journey, we must pull back. We must leave our galaxy behind and see it for what it truly is, a single drifting island of light in an endless dark cosmic sea. Fact 133. Our Milky Way is not alone. It is the dominant member of a small, intimate collection of galaxies, a galactic neighborhood. We call this our local group. This is a small, gravitationally bound cluster of more than 50 galaxies, all moving through the void together, all held in a delicate dance by their mutual gravity. Fact 134. The local group is a galaxy cluster in its infancy. It is a quiet, sparse neighborhood. It is dominated by two great giant spiral galaxies. The first is our own Milky Way. The second, and the undisputed king of our local group, is the Andromeda Galaxy, also known as Messier 31 or M31. Fact 135. Andromeda is our great cosmic sibling. It is located about 2.5 million light-years away from us. This makes it the most distant object in the entire universe that you can see with your unaided eye. On a clear, moonless night, far from city lights, you can spot it in the constellation Andromeda. It looks like a small, faint, elongated smudge of light, a tiny, ghostly cloud. Fact 137. The rest of the local group is composed almost entirely of dwarf galaxies. These are small, faint, disorganized collections of just a few million, or perhaps a few billion, stars. They are the suburbs and villages to the two great cities of the Milky Way and Andromeda. Fact 138. The most famous of these dwarf galaxies are our two closest and most visible companions, the Magellanic Clouds. Visible only from the southern hemisphere, they look like two faint, stationary, detached pieces of the Milky Way. They are named for Ferdinand Magellan, whose expedition was the first to record them for European astronomers, though they were known to indigenous southern cultures for millennia. Fact 148. This event, the Andromeda-Milky Way collision, is the single great defining event of our galaxy's future. It is not a question of if, it is only a question of when. The calculations show this grand, Merger will begin in about 4.5 billion years. Fact 149. What will this look like? It will be the grandest and slowest spectacle in our planet's history. As Andromeda approaches, it will grow in our sky. For millions of years, it will be a faint growing smudge. Then it will become a spectacular rival spiral, filling a huge portion of our night sky. Fact 155. After billions of years of this chaotic dance, the two galaxies will finally completely merge. Their two supermassive black holes will spiral towards each other, finally combining in a cataclysmic event that will send a blast of gravitational waves ripples and space-time itself across the universe. Fact 156. The two beautiful flat spiral galaxies will be gone forever. In their place will be a single, new, colossal galaxy. The gas will be used up. The spiral arms will be destroyed. The result will be a giant elliptical galaxy. A massive reddish-yellow football-shaped, dead galaxy filled with old red stars and no new star birth. We have even given this future galaxy a name. Some call it Milky. Fact 157. This is our ultimate destiny, to become one with our great rival. But what about the universe itself? Our local group is just one tiny sparse cluster. On the largest scales, we see that galaxy clusters are not spread randomly through space. They are organized. Fact 160. All 100,000 galaxies in Mauna Kea are being pulled, like a great river flowing through space towards a single unseen, massive gravitational anomaly, a great attractor. Fact 161. But this entire web, this beautiful, intricate structure ... is itself doomed. In 1998, astronomers discovered that the universe is not just expanding. Its expansion is accelerating, a mysterious anti-gravity-like force. Dark energy ... is pushing everything apart, faster and faster and faster. Fact 162. This dark energy is the true final ruler of the cosmos. Over the next 100 billion years, this acceleration will become dominant. It will begin to tear the cosmic web apart. The great superclusters will be pushed away from each other. The great voids will expand. One by one, the distant galaxies will be pushed away from us so fast, faster than the speed of light, that their light will never be able to reach us. Fact 163. In 100 billion years, our Milky galaxy will look out upon a night sky that is almost completely black. Every other galaxy in the universe, every single one, will have red-shifted out of existence, their light stretched into nothingness by the accelerating expansion. We will be alone. Fact 164. Our great merged galaxy will be a single, lonely, dying island of light in an endless, empty, expanding ocean of eternal darkness. The stars within it will one by one burn out. The red dwarfs will fade. The white dwarfs will cool to black. The neutron stars will spin down. Even the black holes, over trillions upon trillions of years, are thought to slowly evaporate in a final, faint Hawking radiation. Fact 165. This is the heat death of the universe. An end of perfect, cold, dark stillness. An end of all light, all motion, all time. But for now, for this brief, brilliant, cosmic moment, we are here. We are alive. We are adrift on a small blue world. We are orbiting a calm yellow star. We are living inside a vast, beautiful, spinning city of light ... our home. the Milky Way,